See, we are solving examples on oblique components, right? So yesterday we have seen one example, and today we will solve 2 or 3 more examples on oblique components. So you please note down the statement shown on the screen along with the figure. At what angle theta should the force F be directed so that the magnitude of its component along CA does not exceed 80% of the magnitude of its component along BC. So this is the given figure. Force F is applied at point C, which is making an angle theta. So you are asked to find out the angle made by the force, that is theta, for the condition that the component of force along CA does not exceed 80% of the component along BC. It is said that the component along CA does not exceed 80% of BC. Means what is the limiting condition? At the most, it can be equal to 80% of the component along BC. Right? So this is the given condition. And what is the magnitude of force? Magnitude of force is given. Yes?
No, sir.
No. And it is not required also. Now, this force F is to be resolved into 2 components. That is along the line BC and along the line CE. We know that the given force must be between the 2 components. Means the component along CA, I am taking it as F1, and the component along BC, I am considering it as F2. Okay. So I have now the condition F1 is equal to 0.8 F2. As per the notations, what is alpha and beta? Alpha is the angle made by F1 with respect to F. So this angle is alpha, and beta is the angle between F and F2. Right. Let us say in the right angle triangle ABC, I am considering angle C as gamma. So from the right angle triangle ABC, I can write tan gamma is equal to opposite side, that is 4 upon adjacent side 6. That gives you angle gamma. 6,9. Okay. Now, what is angle alpha? Alpha is equal to 180 minus beta minus gamma. So alpha is equal to 180 minus, see here, theta is equal to beta. Okay, it is given the angle made by F with respect to BC as theta and considering that as beta. So it is 180 minus theta minus 33.69. So we have angle alpha 146.31 minus theta, whereas beta is equal to theta. Understood? Now using the given condition, that is f1 is equal to 0.8 f2. What is the formula for f1? It is f sin beta upon sin alpha plus beta is equal to 0.8 into what is f2? It is f sin alpha upon sin alpha plus beta. So by cancelling f and sin alpha plus beta on both sides, you have sin beta is equal to 0.8 sin alpha. Therefore, sin theta is equal to beta is equal to theta. 0.8 sin alpha, that is 146.31 minus theta. Solving this equation, you can get the value of theta. Open this bracket, sin A minus B, sin A cos B minus cos A sin B. 52.63. A 200 Newton force is to be resolved into the components along the lines A dash and B dash as shown in figure. Determine the angle alpha. Knowing that the component along A dash is to be 150 Newton. And what is the corresponding value of the component along B dash? Here lines A dash and B dash are not perpendicular. So the force is to be resolved into oblique components. What is given? The component of 200 Newton along the line A dash is 150 Newton. So this 200 is to be resolved along A dash and B dash. So I am assuming the component along the line A dash is F1 and the component along B dash is F2. So the given force is F. Remember, the force must be between the two components. The sense of the force, sense of the components must be the same. So as per our notations, alpha is the angle between F and F1 and beta is the angle between F and F2. So from figure, beta is equal to 180 minus 45 minus alpha. So it is 135 minus alpha. Given that the component along A dash means F1 is equal to 150 Newton. We know that F1 is equal to F sin beta upon sin alpha plus beta. F1 is 150, F is 200, sin beta is 135 minus alpha upon sin alpha plus beta, that is 135 minus alpha plus alpha minus alpha gets cancelled. Solving this expression, you will get the first answer, angle alpha. So you can take 103. So alpha is 103. Then you have F2 is equal to F sin alpha upon sin alpha plus beta. So it is 200 sin 103 upon sin 135. This is nothing but the component along the line B dash 275.59. Parallel components. Please note down the statement. A kg man stands on a small footbridge at point B, as shown in figure. The man is to be replaced by two persons at A and other at C, so that the external effects on the bridge are not to be changed in the process. And what should be the mass of the other two persons? Means external effect should not be changed. What is the meaning of that? Whatever the effect is there applied by this man of 80 kg standing at B on the bridge, that effect should remain same. Means simply we are replacing the person who is standing at B with two persons at A and C. Other way around, we are resolving the 80 kg which is acting at B into two parallel components at A and at C. So this is the footbridge. Mass of man who is standing at B is given 80 kg. Now we have to resolve this 80 kg into two parallel components at A and C. Distance AB is 1.5 meters, BC is 1 meter. Now say this MA, MC are acting downwards, as 80 kg is also acting downwards. So I can say that this 80 kg is the resultant of MA, MC. So I can write the equation MA plus MC is equal to 80. Say equation 1. Is it clear? I am going to resolve this 80 into two components. Other way around, the sum of those two components is nothing but the given force. So this 80 kg is the resultant of MA and MC. Now to get second equation, we have to use Bernoulli's theorem. What is Bernoulli's theorem? Algebraic sum of the moments of the forces about any point is equal to moment of resultant of those forces about the same point. So taking moments about say point A, you can take moments about any point in the plane. So taking moments about point A and using Bernoulli's theorem, sum of the moments of the forces about point A. So what is moment of MA about point A? The line of action is passing through A. So its moment is 0. Moment of MC about point A. What is the sense? It is creating clockwise sense. So it is minus, it is 0 minus MC into what is the perpendicular distance from the line of action of MC to point A, 1.5 plus 1, 2.5. So this algebraic sum is equal to moment of resultant about point A. Here MB is the resultant. Again it is forming a clockwise moment. So it is minus MB, nothing but 80, into perpendicular distance from the line of action of MB to point A is 1.5. So this is equation 2. From equation 2, you will get MC. From equation 1, NP. Mass of the persons at C and A.
32 kg.
32 kg. And the MC is 40.
48.
Now second example in the parallel components. A force of 600 Newton is acting as shown in figure. Resolve this force into parallel components P and Q. Along the lines, there are two parts. In the first part, you have to resolve along the lines 1, 1 and 2, 2. And second part, along the lines 2, 2 and 3, 3. So here 600 Newton, it is acting vertically upwards. So the first part is, you have to resolve into the components P and Q. Along the lines 1, 1 and 2, 2. So here the force, it is acting vertically upwards. Initially I will assume that both the components which are acting along the line 1, 1 and 2, 2 upwards. Along the line 1, 1 I am saying it as P. Along the line 2, 2, it is Q. Now we are resolving the 600 into two components P and Q. Other way around, the 600 is the resultant of P and Q. So I can write the equation P plus Q is equal to 600. So this is equation 1. For second equation, use Berigna's theorem. So I am considering point O on the line of action of P. See, to use Berigna's theorem, you can take moments about any point in the plane. So why I am taking this point O on P? Because I can eliminate the moment of P about point O. It will be 0. To make the calculations simple, I am considering this point on the line of action of P. So taking moments about point O and using Berigna's theorem. Algebraic sum of the moments of the components about point O is equal to moment of the force about point O. So moment of P about point O is 0. Moment of Q about point O. What is the sense? Sense of rotation anti-clockwise. So it is plus Q into what is the perpendicular distance from the line of action of Q to point O. 5x, right? So into 5x. This is equal to moment of force about point O. Again, this 600 Newton is forming anti-clockwise moment. So it is plus 600 into what is the perpendicular distance? 2x. So solving this equation, you will get Q from equation 1, P. So we have P as plus 360. You are getting P plus means the assumed direction is correct. It is upwards. And Q is 240. And it is upwards. Component along the line 2, 2. I am saying it as P. And the component along the line 3, 3 as Q. So you have to resolve these 600 into components along 2, 2 and 3, 3. I am assuming initially both are upwards. This is the assumption. If you get the positive answer, your assumption is correct. Suppose if you get negative answer, you have to change the sense.
Sir, can you repeat it once again?
Say now, this 600 Newton is to be resolved along the lines 2, 2 and 3, 3. Components P and Q. To start with, I am assuming that these two components are acting upwards. I am assuming the upward sense. After doing calculations, if you get the answer as positive answer, that means your assumption is correct. Suppose if you get negative answer, that means the sense must be opposite. Suppose if you get P is equal to minus 500, for example, which means that the magnitude of P is 500, but it is acting vertically downwards. Okay, that we will see now. The second part, P and Q along the lines 2, 2 and 3, 3. So we are resolving 600 into two components P and Q. Other way around, the resultant of P and Q is 600 Newton. So the first equation will be P plus Q is equal to 600. Say equation 1. For the second equation, we are to use Bragg-Knopf's theorem. So taking moments about point O and using Bragg-Knopf's theorem. So where you will consider the point O? You can consider it on P, on Q, or even on 600. So let us consider on point line of action of P. Say that is point O. Okay. Now sum of the moments of P and Q above point O is equal to moment of 600 above point O. So what is moment of P above point O? 0. Line of action is passing through it. Now moment of Q about point O, what is the sense? It is creating clockwise sense. So it is minus Q into perpendicular distance is 2x. This is equal to moment of 600 Newton about point O. Again 600 is creating clockwise sense about point O. So it is minus 600 into what is the perpendicular distance? 3x.
3.
So this is equation 2. Solving this, you will get Q, and from equation 1, P. So getting Q is equal to 900. And P is equal to minus 300. So see here, Q we are getting positive answer, and we have assumed that Q is upwards. So it is upwards. Whereas P we are getting negative answer, but we have assumed that P is also upwards. Which means it is 300 Newton acting downwards. So these are the magnitudes of P and Q along the lines 2, 2 and 3, 3. Do you have any confusion regarding this plus minus sense of the forces? To start with, initially we are assuming that the components are upwards, and after doing calibrations we are getting negative answer, which means the assumed direction is wrong. It is opposite. A tugboat exerts 2.8 kN force along its axis on a barge at point B as shown in figure. Replace the force applied at B with an equivalent system formed by two parallel forces applied at A and C. Equivalent system formed by two parallel forces means the effect of that new system and the effect of the given system should be the same. What is the given system? 2.8 kN force acting at B at an angle 65 degrees. So whatever the effect that force is having on the barge, the same effect you should have when you replace that force with two parallel forces at A and C. That is the meaning of that. So in short, you have to resolve 2.8 kN force which is acting at B into two parallel components at A and C. The 2.8 kN is acting at B, making an angle. Find out equivalent system having two parallel forces at A and C. It is said that two parallel forces. Nothing is mentioned about whether those two forces must be vertical or any particular direction. So I will consider those two forces, parallel forces at A and C in the direction of the given force. I will call this as Fa, force at A, and a force at C as Fc. Whereas this given force is Fb. Remember, this Fa and Fc are in the same direction of the given force 2.8. Means Fa, Fc are parallel. Right? So I am replacing this 2.8 kN with two parallel forces at A and C. But the direction of those two forces is also 65. So the first equation is Fa plus Fc is equal to 2.8. Because 2.8 is the resultant of Fa and Fc. For the second equation, we have to use Berigna's theorem. So taking moments about point, any point you can consider in the plane. So I will consider point A. So taking moments about point A and using Berigna's theorem. You should not ask me why you have selected point A. Even you can select point C also, point B also, any point you can consider. Now sum of the moments of Fa and Fc about point A must be equal to moment of 2.8 about point B. So what is the moment of Fa about point A? The line of act is passing through it. So it is 0. And moment of Fc about point A, moment of force is equal to force into magnitude, product of the magnitude of force into perpendicular distance from the line of action of the force to point A. Say I will consider this, I will write this as DC. We know that this is 65 degrees. Now from this right angle to triangle, what is this perpendicular distance DC? 65 is opposite side. DC means hypotenuse is 72 meter. 27 plus 45. So you get a triangle, opposite side is sine, right? So DC is equal to 72 sine 45. Is it clear? Now what is the moment of FC about A? What is the sense? It is creating anti-clockwise sense. So it is plus FC into perpendicular distance DC, that is 72 sine 45. This is equal to, sorry,
Sir, it was
Sir, it should be
65 degrees.
65.
65, sorry, 65, right, which is equal to moment of 2.8 about point A. Again 2.8 is forming anti-clockwise moment. So it is plus 2.8 into perpendicular distance from the line of action of 2.8 to point A. This distance. I am saying this is dB. Again you have this as 65 degrees. From the small right angle triangle, opposite side dB is equal to 27 sine 65. 27 sine 65. So into 27 sine 65. Say this is equation 2. From equation 2, you will get FC. From equation 1, at A. Two parallel forces at A and C. FC is 1.05 kilonewton. FA is 1.75 kilonewton. But what is the direction? Making 65 degrees with the horizontal. The direction same as the given force. Okay, any doubts? With this, we have completed the second chapter. So in the next class, we are going to see the third chapter, which is force coupled systems.